Welcome to the podcast. Today, we're diving into this fascinating development, an anti-aging injection that regenerates knee cartilage. Researchers at Stanford Medicine found that by blocking a protein called 15-PGDH, they can actually reprogram the existing cells in the joint, getting them to produce more youthful cartilage.
Yep. So this treatment in animal models was able to not only rebuild worn-out cartilage, but also prevent arthritis from developing after typical injuries like ACL tears, right?
Exactly. What's really interesting is that it works by reprogramming the chondrocytes, the cells that generate cartilage, rather than relying on stem cells. It's like getting your own cells back to their younger selves.
Right. And I heard there's also a pill-based version in the works targeting muscle weakness. That seems even more intriguing.
Yep, that's spot on. They're already testing that one in clinical trials. It just goes to show how versatile blocking 15-PGDH might be, not only for regenerating cartilage, but potentially for strengthening muscles and maybe even affecting bone and nerve repair.
Now, here's my question. We all know that promising results in mice often don't directly translate to humans. Isn't it a bit premature to get too excited?
That's a totally valid concern. The research is indeed preclinical, and while they've also seen positive responses in human knee tissue taken during joint replacements, meaning the tissue started to form new functional cartilage, we still have a long way to go before it becomes a routine treatment.
And about the mechanism, so instead of using external stem cells, this injection shifts the gene activity of existing cells to promote regeneration. That sounds revolutionary, doesn't it?
Yes, exactly. By targeting the age-related increase in 15-PGDH, they can effectively prompt the chondrocytes to re-express a more youthful state. It's like resetting the clock on those cells, which in theory could mean less pain and maybe even avoiding knee or hip replacement surgeries in the future.
But there's a flip side too, right? Some experts point out that altering gene expression in these cells might bring unforeseen issues or even trigger undesirable side effects like heightened pain sensitivity when prostaglandin E2 is involved.
I agree, and that's where the caution comes in. The study clearly states that more clinical trials are needed to nail down the long-term safety and efficacy in humans. We have to be careful not to let this early promise overshadow the rigorous testing still needed.
Absolutely. It's such a significant step, though. Osteoarthritis affects nearly 1 in 5 adults in the US and drives billions in healthcare costs. An intervention that targets the root cause could change the whole game.
Definitely. Instead of merely managing pain, this approach gets to the underlying cause of cartilage degeneration. If further trials bear out these findings, it could mean a major shift in how we treat not just osteoarthritis, but other age-related joint issues too.
Yep. So while the science is super exciting, it's still early days. We need more data before people start thinking about skipping surgery for an injection.
Exactly. It's a promising leap forward, but for now, it's a beacon of hope, a truly innovative concept that needs further exploration. Thanks for joining in on this deep dive into what might be a very transformative treatment.